So this video is going to cover vertical asymptotes and horizontal asymptotes for rational functions, okay? What they are and how to find those, okay? So first off, let's define those. Vertical asymptotes. They're going to be vertical lines which correspond to the zeros of the denominator of a rational function once it's in simplest form, okay? When we find those vertical lines that the graph cannot touch or cross, okay? They will never cross these vertical asymptotes, because those values are excluded from the domain of the graph, okay? The reason this happens, the function is undefined at those zeros, okay? There are also some possible values that will make the denominator zero, but they would be a different circumstance. We're going to call those removable discontinuities or holes, okay? And they're going to be covered in the next set of notes, okay? For now, we're just worried about vertical asymptotes, not all discontinuities for rational functions, okay? Horizontal asymptotes, they're not as absolute as vertical asymptotes, okay? They just suggest what the behavior of the graph is going to be as we move off to the far left of the graph and to the far right of the graph, okay? Graphs of rational functions can, sometimes do touch or even cross the horizontal asymptotes, but on the extreme left and the extreme right of the graph, these horizontal asymptotes will be suggestive of the behavior of the graph, okay? All right, so we've already talked about how to find the vertical asymptotes. Determining the horizontal asymptotes is a little bit more difficult, okay? So let's say we've got a rational function, and the only thing we're kind of worried about here is the degree of the numerator, and we're going to call that n, and the degree of the denominator, which we're going to call m, okay? All this other mess out here to the side is irrelevant when we're determining whether or not the function has horizontal asymptotes or not, okay? Now, having just said that, not all rational functions will have horizontal asymptotes, okay? There's two cases when we compare n and m where there will be a horizontal asymptote. There's one case where there is not a horizontal asymptote. So let's look at those, okay? Again, first off, the vertical asymptotes are going to be the values that make the denominator zero once we're in simplest form, okay? Now, part two, finding the horizontal asymptotes. If the degree of the numerator n is less than the degree of the denominator m, okay, then we're going to have a horizontal asymptote at y equals 0, the x-axis, okay? And if you remember back to the previous video, graphing the parent function for rational functions, the degree of the numerator was smaller than the degree of the denominator. Therefore, we had a horizontal asymptote at y equals 0, okay? If the degree of the numerator n is equal to the degree of the denominator m, then we're going to divide these coefficients, okay? Notice the horizontal asymptote will have the equation y equals leading coefficient of the numerator divided by leading coefficient of the denominator, okay? And I'll show you how that works in just a second, okay? So again, restating, if the numerator and the denominator are of the same degree, if they're both quadratic, if they're both cubic, if they're both fourth degree, then we're going to have a horizontal asymptote at y equals the ratio of the leading coefficients, okay? If the degree of the numerator is greater than the degree of the denominator, we're not going to have a horizontal asymptote. There will be no horizontal asymptote. There will, however, be a slant asymptote, and we'll cover that in notes that happen later on, okay? So let's do these four examples here. First function, f of x equals 2 over x minus 3, okay? This is already in simplest form. I can't simplify it anymore, okay? So the vertical asymptote will be the value that makes this 0, okay? So that's going to be x equals 3. So we're going to have a vertical asymptote at x equals 3. The graph will never touch or cross that vertical line, okay? Horizontal asymptote. Degree of the numerator is 0. This would be like 2 times x to the 0. The degree of the denominator is 1, okay? So the n is going to be less than m, so we're going to have a horizontal asymptote here at y equals 0, okay? All right, let's look at 2. G of x equals 3x plus 5 over x plus 2, okay? This is in simplest form, so I can determine the vertical asymptotes, okay? So the value that makes this 0 is going to be negative 2, so that's my vertical asymptote. Degree of the numerator, degree of the denominator, both 1, they're the same. So that means we're going to have the ratio of the leading coefficients, okay? Well, the leading coefficient in the numerator is 3. The leading coefficient in the denominator is 1. So my horizontal asymptote would be at 3 over 1, or y equals 3. Okay, the horizontal line where y equals 3. Okay. 3, h of x equals this quadratic over this quadratic. Okay. Not in simplest form. I can factor both the, I can just factor the denominator here. The numerator can't be factored. Okay. You could try, but it would never happen. All right. So my vertical asymptote is going to be what makes this factor 0. Okay. In this case, it's going to be x equals 1. Okay. Horizontal asymptote, degrees of the denominator and the numerator are both the same. So it's going to be the ratio 2 over 1. So y equals 2 will be my horizontal asymptote. Okay. And problem 4 here. We've got quadratics again. So I already know what my horizontal asymptote is going to be. It's going to be 3 over 2. But let's factor. Okay. You can factor the numerator to this combination of binomials. You can factor the denominator as this pair of binomials times each other. Okay. None of these can cancel out, so we're in simplest form. Okay, so we're going to have 2 vertical asymptotes here. What makes this 0 is 1/2. What makes this 0 is -2. So notice I've got those 2 vertical asymptotes. My horizontal asymptote, again, degrees are the same, so it's just going to be 3 over 2. So y equals 3/2. Okay, so that's how you find vertical asymptotes and horizontal asymptotes if the rational function has them.